far beyond the reaches of the four rocky planets lurking on the opposite side of the asteroid belt we find our solar system's showpiece worlds, the two gas giants Jupiter and Saturn. As the two largest planets, both exhibit their own range of fascinating phenomena, making them tantalizing targets for probes exploring the planetary neighborhood. But with their tremendous gravitational influences, their irradiating magnetospheres, and above all their vast distances, reaching these worlds with a probe presents a much greater challenge than traveling to one of the terrestrials. But in the early 1970s, the technology for more reliable probes capable of long voyages was primed, and missions to both Jupiter and Saturn ensued, and it is those missions that make up the topic of our video today. In this second episode on our trilogy of probes that studied the solar system, we will re-examine their revolutionary findings over the years, from snapping, breathtaking shots of their upper atmospheres to revealing seismic secrets about the moons that surround them. This is our journey to the gas giant planets. The gas giants are the two principal planets of the solar neighborhood, both a stunning, striking worlds with rich extended atmospheres, each showcasing their own plethora of extreme weather processes. Any journey into their territory starts with Jupiter, the godfather planet, more than double the mass of all the other worlds combined. The clouds swirling in its upper atmosphere weave a vibrant tapestry of our solar system's oldest and largest planet. Saturn, on the other hand, is the solar system's crown jewel, with a smoother surface and an even greater number of moons, along with one of the most spectacular sights in space, its unparalleled planetary ring system. Furthermore, both of these giants host their own collections of planet-sized moons, some with eyebrow-raising prospects for habitability. As such missions to study the gas giants have often found themselves at the top of NASA's to-do lists, with the first Jupiter-bound mission conceived as early as 1959. However, both worlds lie significantly farther from the Sun than the planets of our terrestrial neighborhood. The closer of the two, Jupiter, is around 5 times the distance separating the Sun and the Earth, while Saturn is around double that. As such, a voyage to either of these two worlds would take years instead of months, and for the planets lying beyond Saturn, whole decades would be required. It didn't seem feasible for the somewhat temperamental, short-lived probes of the late 1950s, which had barely begun to escape Earth's gravity, and so moving into the 1960s, as NASA set their sights on the bodies of the outer solar system, the scientists at their Jet Propulsion Laboratory began investigating ways to trim down this journey time using both clever engineering techniques and natural means. As we covered in the last episode, humanity's maiden voyages to both Venus and Mars were launched during their respective windows of closest approach, i.e. when the orbits of either planets align them most closely with the Earth, enabling the simplest, shortest trajectory between the two. And in 1964, a study by the JPL revealed that a similar planetary alignment event involving all 4 of the large planets would take place sometime in the late 1970s, the likes of which only occurred once every 177 years. This would present a once-in-a-lifetime opportunity to visit each of the giant planets, and perhaps even Pluto, with a spacecraft in only a fraction of the time required otherwise, by using each stop along the way for a gravitational boost as we touched on last time. It had long been known by scientists that when icy comets such as the comet Halley passed by a planet, their velocities seemed to increase on the way out as they received a gravitational assist. Upon exit, applying this technique to a probe, specifically one flying by Jupiter, would induce a similar gravitational slingshot effect which could effectively treble its speed and correct its course without the need to carry any extra fuel, pruning the journey time to Neptune down from around 4 decades to about 1.5. As such, the JPL quickly conceived of an ambitious series of long-distance probes that would make use of this alignment by using Jupiter as a stargate to visit all 5 of the then contemporary planets in the outer solar system. This project would eventually materialize as the world-famous pair of Voyager probes, but that is a story for another day. In the meantime, however, NASA sought to practice this gravitational slingshot maneuver before the Voyagers arrived, while also ticking off their now most depressing planetary targets, Jupiter and Saturn. And so in 1969 they signed off on a pair of probes as part of their Pioneer program, a dormant series of spin-stabilized probes, which had some years earlier been used to study space weather. These missions, however, then designated Pioneer F and Pioneer G, would carry over old successful designs to create a new, more streamlined and resilient pair of probes fit for a much longer interplanetary voyage, one which would take them to the outer solar system. The former, today known as Pioneer 10, would become the first probe to cross the asteroid belt and reach Jupiter before receiving a gravitational boost and ultimately shooting off into deep space. Pioneer G, on the other hand, today known as Pioneer 11, would repeat these same steps but would then use its gravitational boost to carry on to the other gas giant planet, Saturn. Hundreds of scientific experiments were proposed for both spacecraft, and their construction was estimated to have required more than 25 million working hours aboard. Their final set of mounted instruments were helium magnetometers, plasma probes, charged particle detectors, cosmic ray telescopes, radiation detectors, asteroid and meteorite trackers, Geiger tube telescopes, and finally optical instruments for studying invisible ultraviolet and infrared wavelengths. Pioneer 10 launched from Cape Canaveral on the 2nd of March, 1972, spending about 4 months making its way towards the inner edge of the asteroid belt between Mars and Jupiter. It would enter this circumstellar fence of rocky projectiles on the 15th of July, but unlike the stuff of science fiction, its passage was smooth, barely straying within 10 million km of a large object during 7 months on the inside, and save for some negligible impacts with dust particles, Pioneer 10 emerged from the asteroid belt unscathed on the 15th of February in the following year, where it started to return the first heliophysics data from the space beyond the terrestrial neighbourhood. It probed the solar winds and cosmic dust for their chemical constituents, while also detecting the first helium atoms from interstellar space after clearing the asteroid belt. Pioneer 10 maintained its outwardly passage for a further 9 months before eventually coming within 25 million kilometers of Jupiter and initiating its observations phase on November the 6th. In the month that followed, the probe homed in on the Godfather planet and studied its surrounding environment. In doing so, it amassed the first collection of more than 500 groundbreaking images of the giant planet and its great red spot before making its closest approach on the 3rd of December, but as the craft crossed Jupiter's magnetic equation later it was exposed to a huge electron flux some 10,000 times stronger than the most corrosive surrounding Earth. This wreaked havoc on the probe's instruments by generating a series of erroneous commands which threatened to derail the mission altogether. While its engineers were able to rectify most of the troubling issues, only 6 of the spacecraft's 11 core instruments remained operation as they were turned back to image Jupiter's moons. As a result, an image of the moon Io as well as some close-ups of Jupiter itself were lost, and while the craft was able to capture 2 of the other Jovian moons, Europa and Ganem, only images of the latter yielded any meaningful detail. Upon starting its exit from the Jupiter system on December the 4th, Pioneer 10 became the first probe to receive a gravitational assist from another planet, catapulting the craft on route towards its final destination, interstellar space, having acquired so much velocity from its trajectory through the Jupiter system. Pioneer 10 had now been set on an irreversible path, becoming the first man-made object to reach the solar system's escape velocity. The speed need to overcome the gravity of the Sun for the duration of the journey, beyond covering more than 500 million km a year. Pioneer 10 crossed the orbit of Saturn just 3 years later in 1976, followed by the orbit of Uranus in 1979 and then Neptune in 1983. It would continue along this path for another 15 years, almost before its vanishingly weak signal became too faint to transmit any readable data. But while the mission was officially concluded on the 31st of March 1997, Pioneer 10 would continue to beam back the occasional featureless telemetry signal for a further 6 years. In fact, the very last contact with the probe was on the 23rd of January 2003 from a distance of more than 80 astronomical units, finally capping off what was originally intended as a 21-month mission after more than 30 years, a true testament to the craft's engineering and the time that was invested in future-proofing its design. Just over a year after the launch of Pioneer 10, the subsequent follow-up mission, then known as Pioneer G, was prepared to follow. Like the former, this spacecraft would float across the asteroid belt on routes to the Jupiter system before passing the large planet to receive a gravitational boost. But unlike its predecessor, which was slingshot straight into deep space, Pioneer 11 would carry on towards the other gas giant, becoming the first probe to visit the solar system's crown jewel. There it would study its atmosphere, magnetosphere, and its planetary rings, as well as the many intriguing moons in orbit around the giant. And upon completion of those pre-programmed objectives, Pioneer 11 would be used to test a slingshot maneuver of its own, flying through Saturn's ring plane. The probe lifted off from Cape Canaveral on the 5th of April 1973, embarking on an 18-month voyage to Jupiter through the asteroid belt. It encountered the giant planet in early November 1974 and made its closest approach a month later on the 2nd of December. It came within just 43,000 kilometers of Jupiter's cloud tops, 3 times closer than its counterparts the year before, but it did so at a much higher velocity, resulting in less prolonged exposure to damaging radiation as such. All of the craft's 11 instruments this time survived there. Encounter snapping over 200 even sharper images of the planet, including the first shots of its polar region and more of its swirly outer atmosphere. The probe also enjoyed more success in studying the Galilean moons, snapping shots of Io and making measurements of Callisto, where Pioneer 10 was unable upon receiving its bespoke gravitational boost. Pioneer 11 would venture onwards for another 5 years before encountering its next target, Saturn, on the 29th of August, 1979. Pioneer 11 entered the Saturn system and spent 3 days sinking towards the planet en route to its closest approach, just 21,000 kilometers from its outer edge, snapping increasingly close up all the while it then became the first probe to cross Saturn's ring plane as a dry run for the voyage of spacecraft which were already en route to the gas giant, in order to receive the kind of gravitational boost from Saturn required to push further out into the solar system. It is necessary to fly close enough to the planet that the extended ring plane of particles must be breached. Therefore, Pioneer 11 would practice flying through a gap in Saturn's rings in order to map a sufficiently clear route for the voyagers, and if it had sustained any serious damage upon colliding with unseen moonlets, Voyager 2's ice giants mission to Uranus and Neptune would probably have been scrapped, but Pioneer 11 glided through smoothly with no problems and received a gravitational assist from Saturn that sent it hurtling